4.3, trig extended. AKA we're just doing more with it. Circular functions. Huh?
That just makes it sound long.
Yeah.
Very stretchy trig.
Did y'all have notes for this section or no? No? Okay. Most of this will be stuff that you've already seen before, so that's probably why I don't have one. So, we have, when you have an angle, this is your initial side. This is like angle A, and this is your terminal side. Finding coterminal angles. For degrees, we do theta plus or minus 360 degrees. And for radians, it's theta plus or minus 2 pi or some increment of 2 pi. Okay, obviously it could be 4 pi over 2. It could be 6 pi over 3. Things like that. Any increment of 2 pi would be what we're using for that. The next little thing I'm not going to really write, but quadrant 1 is top right, quadrant 2 is top left, quadrant 3 is bottom left, quadrant 4 is bottom right. It goes around in order. But basically, you know that, sine and cosine are positive in quadrant 1, so tangent is also positive. In quadrant 2, sine is positive, cosine is negative, so tangent is negative. Quadrant 3, sine and cosine are both negative, so tangent is positive. And then quadrant 4, cosine is positive, sine is negative, so tangent is negative. So it's all the stuff that you already know from your unit circle, so I don't feel like you need to write all of that down, but anyways, just something to think about. So the first ones, I honestly like the way the Algebra 2 book does coterminal better, but the first problems, they give you 5 values, and they want to know, or they want you to find the one that's not coterminal with the rest of them. So number 2, 5 pi over 3, negative 5 pi over 3, 11 pi over 3, negative 7 pi over 3, and 365 pi over 3. Yeah, that one sounds awful.
I'm sure it's not as bad as it sounds. Either that or it's just worse.
Now, these are all pi over 3, so what increment of 2 pi am I using?
Pi over 3.
Pi over 3 isn't equal to 2 pi.
Bridging out.
6 pi over 3. Okay, that's equal to 2 pi, and that's what I have to add and subtract from each one.
I think I'm ready for the advanced class.
Alright, so we're going to take, I would honestly just start out with 5 pi over 3 and add 6 pi over 3 to it, and then do some subtracting, and hopefully I get one that isn't coterminal before I get to the 365 and have to add a million times. But anyways, I would always start out with whatever the first one is that they give you. So plus 6 pi over 3 would be 11 pi over 3. So those two are coterminal with each other. So next I would probably start subtracting, to be honest, at that point, because again, otherwise I have to go up to 365 pi over 3, and that's just not cool. So 5 pi over 3 minus 6 pi over 3 would be negative pi over 3, which isn't on my list, but I'm going to do it again. So minus 6 pi over 3 would be negative 7 pi over 3. And so that would be 1. And that tells me that I went from negative pi over 3 to negative 7 pi over 3. So that means that this negative 5 pi over 3 is the one that's not coterminal. So this is the one that I'm trying to find, which tells me that that one is going to have to be coterminal because there's only one that's not, according to the instructions. Otherwise, you could basically just keep adding 6 pi over 3 or whatever to it. You could multiply by like 20 and and then do it, and that would also work to give you that. But anyways, it's going to be coterminal because only one of them is not. Let's see. But I don't know if y'all remember last year when we were finding a positive and a negative coterminal angle, and we were just like adding or subtracting till we had like the first positive and the first negative one. But that's honestly how I think the exam would be more inclined to ask it to you. Now, I could be wrong. It could give you a multiple choice and be like, here's your angle. Which of these options is not coterminal with that given angle? And your multiple choice options, it could be like this. So it could be this way, but you would just add or subtract 2 pi, like increments of 2 pi or increments of 360 to find other coterminal angles. So yeah. All right, the next thing in here, this is where I'm getting confused because I thought we'd already done this in this class, but I guess I did it in algebra too. They give us a point, like -4, -6, and we need to graph that point, and then it wants us to solve for all 6 trig functions of theta. If something happens to be undefined, then we'll write undefined. So basically, if it's on an axis, we would have something that could be undefined at that point, which you might remember as a quadrantial angle from last year, but you also might not because it's a really weird word, and I don't usually think about it until I start teaching it. So I'm going to plot this point. What quadrant is this point in?
3.
Quadrant 3. So it's going to be down here. Oh, nope, none of that. Remember that when we draw these, it's always touching the x-axis, okay, not the y-axis. So when we draw it, it's always going to be, no matter where we draw it, okay, even if it was, I'm just going to do this for right now so I don't have to draw another one. If it was up here in quadrant 2, it would be there. If it was in quadrant 1, it would be like this. If it was in quadrant 4, it would be like that. Okay, they're going to be touching the x-axis all the time. Okay, but we're looking at the one in red. So I'm going to get rid of those ones. So I need to label the sides. So x is -4, y is -6. And normally we're like, we can't have negative lengths, but in this case we can. So I need to find the hypotenuse side, or we often call it r in the situation of trig. But anyways, I need to find the other side, so how would I do that? Pythagorean theorem. So it's going to be the square root of 6 squared plus 4 squared, and I can just drop the negatives because they're being squared, so they're going to become positive anyways. So that's going to be the square root of 36 plus 16, 52. So now I've also got the square root of 52 on here, and then I can relatively easily find all 6 trig functions because I know I've got some square roots in here. I'm going to wait and write the other 3 after I do these. So what would the sine of theta be? And theta is always this angle at the origin. So what would sine of theta be? and rationalize it, you would get
-6 square root of 52 over 52.
can I do anything else?
Use.
Three root 52 over 26.
So take out a 2. So negative 3 root 52 over 26. But that's why I said I was going to wait and write the other ones because I was like, I'm not going to have room. All right, cosine of theta.
-4 square root of 52.
And rationalized, that would be negative 4 root 52 over 52, which will reduce to,
Negative root 52 over 13.
yep, negative root 52 over 13. That one reduced nicely. Tangent of theta. Yeah, negative 6 over negative 4. Negatives cancel, and it reduces to 3 over 2. So cosecant of theta would then be what?
Negative square 52 over 6.
Yep, negative root 52 over 6.
Would you want us to, I don't know if the term would be simplify, but like, would you want us to do that with root 52 and make it 4 root 13?
I don't care. I usually just leave it, but I don't know. The book, the answers aren't in the front, so I don't know which way they do it. I'm sure they do reduce it down. If you want to, that's fine. I would say at least make sure you know how to reduce it down. Like, I think you know how to, like, pull things out of a radical. Because on the AP exam, they more than likely the multiple choice questions, if this is involved, is going to have you, like, pulling stuff out and having it simplified. I would say if it's a short answer question, you certainly should simplify it. So if you want to get in the habit now, that's fine. Either way. But yeah, you could write it as, what, 2 root 26? No. 2 root 13. Huh?
2 root 13.
2 root
That.
13. Yeah. So if you wanted to do it this way, anywhere that we had a square root of 52, you could do it that way. And it also would have allowed the reducing to have been a little easier. The reducing would have kind of already naturally been done for us. But anywhere there's a square root of 52, we could rewrite it this way. So just FYI. Secant of theta.
-52 or negative square root of 2.
I know what you meant.
Okay, good.
Cotangent.
2 over 3.
2 over 3. Yeah, and obviously, like with secant, let's say we had swapped that to negative 2 root 13 over 4. That would end up reducing to negative root 13 over 2. So, I know it's really tiny, but anyways, that would be how that would reduce down, which I think, y'all are good enough to do that. But if we had started out with this, then we would have just used that all the way down. But since I had already done it, I'm not going to go back and redo all of them. But on the next one, if we have that, we'll work accordingly. All right, 10. The point is negative 3, 0. So where's that? On the x-axis. So that's going to be basically over here.
That's nice.
So that's negative 3. So now, So sine of theta. This is where we have to throw it back to when we had like for cosine is like x over r, sine is y over r. And so we have to think about this as to figure out r. So x is -3, y is 0. R is going to be the square root of 3 squared plus 0. Okay, so r is going to be 3. So when we do this, we need to think about sine as if it is y over r, cosine is x over r, tangent is y over x, and then we'll flip them obviously like normal for the other stuff. So y over r would be 0 over 3, which is 0. Cosine is x over r, which is -3 over 3, which is going to be -1. Y over x is 0 over -3, which is 0. There. So then cosecant would be what? Undefined. Okay, because it would be 3 over 0, which is a problem. Secant of theta would be still -1, and cotangent of theta would be undefined. So I'm not going to say 100% of the time because, there's always that random chance. But most of the time, you're going to have 2 that end up being undefined. You're going to have 2 that are 0, and then 2 that are like a 1 or a -1, depending on where it falls. But that's how you would do those, and that's what it means, like, when it says it could be undefined. If it's on an axis, that's the only time that's going to happen, though. Let's see. All right, these next ones say to state the sign, positive or negative, for the sine of t, cosine of t, and tangent of t, and t is somewhere in the given interval. So basically, they give us an interval from pi over 2 to pi. So what quadrant is that in? 2. Top left is quadrant 2. Okay, so it wants to know
I was thinking that was a point.
the sine, the sine, S-I-G-N, of sine, S-I-N, of cosine and of tangent. So is sine positive or negative in quadrant 2?
Positive.
Positive. Is cosine positive or negative?
Negative.
Tangent then would be
Negative.
negative. So as you see, these are rather uneventful problems.
It's nice to be uneventful sometimes.
16, 3 pi over 2 to 2 pi. What quadrant is that?
4.
Quadrant 4.
Yeah, I got it right this time.
So what is sine there?
Negative.
Cosine is?
Positive.
Tangent is?
Negative.
There you go. Also why I didn't feel the need to write them in your little notes, because you literally were going to have problems where you have to do them. So I think you got it under control. If not, we probably have bigger issues than,
Figuring out the signs.
yeah.
Yeah, if we can't figure that out, then
User error.
us.
Determine the sign of the given value without the use of a calculator. You're probably like, that's what we just did, isn't it? 18. The tangent of 192 degrees. Is it going to be positive or negative?
Negative. Anti-negative.
I just want to put this out.
Like positive.
It's positive because it's in what quadrant?
3.
This is in quadrant 3, okay, because it's bigger than 180, less than 270. So this is going to be positive because sine and cosine are both negative there.
For some reason I thought it was in quadrant 2.
Not that one.
Yeah.
20. The tangent of 4 pi over 5. What quadrant would that fall in?
2.
Quadrant 2, because it's less than pi. Okay, because 4 over 5 is less than 1, so it's going to be less than pi. So this is going to be in quadrant 2, so top left. So what is the sign of that going to be? Negative. Easy enough. All right. What's the next thing? Virginia, how long do you think you need to take your unit circle?
I don't think it should take me that long.
Okay.
And if I go, I don't really think we're doing anything or much.
I only have 4 problems left, so I was just trying to see where we're at with time to make sure you were gonna have. Yeah. Anyways. Okay. 22. So these ones say to choose the point on the terminal side of theta. So it gives us theta is equal to 2 pi over 3. And it wants to know which point aligns with that. Okay. So it gives us 3 points. Point A is negative 1, 1. B is negative 1 root 3. And C is negative root 3 and 1. And so it wants us, essentially what's happening is we're looking at the unit circle at 2 pi over 3, and I'm trying to figure out which of the points that I was given, A, B, or C, make up the value that I need for here, essentially. The easiest one, in my opinion, to use is tangent because it uses x and y. We don't have to find another point, right? So I know that the tangent of 2 pi over 3 is equal to negative root 3. So basically when I solve these, I need the one that's equal to negative root 3 when I'm done. So tangent is y over x. So I'm going to do tangent of theta is equal to 1 over negative 1. So that means that the tangent of theta is equal to negative 1, which I know is not there. Okay, if you forget what it is, you could take the inverse tangent and find it. But tangent of theta equal to negative 1 is at 3 pi over 4, so it's not that one. This one, tangent of theta is equal to root 3 over negative 1, which means tangent of theta is equal to negative root 3. Well, that is negative root 3 is at 2 pi over 3, so this would be the point that I'm looking for. But if you wanted to, check and make sure, tangent of theta over here would be equal to 1 over negative root 3, which rationalized would be negative root 3 over 3, and that would occur at 5 pi over 6. So it would be this one. Does that make sense? Are we okay with that? Cool. I can do another one of those if we need to, but if y'all are like, no, we got this under control. I would just say with those, use tangent. It makes your life easier because then you don't have to find the third side. And that's just a pain. So. All right, the last ones on here, are evaluate without using a calculator by using the ratios in a reference triangle. Personally, I would just get them off the unit circle. Way easier. I mean, that's kind of what it means by reference triangle, but at the same time, they want you to... Anyways, basically, do this is essentially what they want you to do when you're given an angle, and that just seems like a lot. So I would just use the unit circle. So 26 is the tangent of 300 degrees. So what is the tangent of 300? Negative root 3. I didn't realize you had your unit circle out, and I was like, man, you did that really fast.
No, some people
I was
are
about
like
to say that without my unit circle. It's gonna be so proud of me.
All right, 28. Cosecant of 3 pi over 4. So with cosecant, what trig function do we think about? 1 over sine. So I would think about this as 1 over the sine of 3 pi over 4. And what is the sine of 3 pi over 4? Yep. So we have 1 over root 2 over 2, which keep, change, flip is going to give me 2 over root 2, which is ultimately going to give me, with everything canceling, root 2. I didn't feel like writing 2 root 2 over 2.
I was totally gonna just say root 2 from the start, but I, for some reason, just stayed silent. I think I had a bit of lag.
Well, and I mean, the other thing is, if you didn't want to think about it that way, you could have gone straight to, well, I know that whatever the sine value is, I just need to flip it over, and you could have said, okay, well, flipping it would have been 2 over root 2, and then you could have gone to root 2 that way if you wanted to. But this is the way I've been doing it with Algebra 2 and the way you would have seen me do it last year, because I don't often think that they're quite ready for the just flip it. So, anyways, if you want the shorter method, what's in red is the shortcut. Otherwise, what's in blue is what you would have learned last year.
I just realized the arrow from the sides is smiling face.
It's smiling at all the twos. Riley was not.
I was very unimpressed.
All right, how about the cosine of 17 pi over 4?
Oh wait, can't use a calculator?
So that's the same thing as pi over 4.
Yes. Okay, now, there's a couple things you could do. You could find the coterminal angle that's on your unit circle by subtracting 8 pi over 4, because that's increments of 2 pi, until you get down to something that you know, okay? Or you can take your unit circle if you don't want to find a coterminal, and we can count it out. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4, 10 pi over 4, 11 pi over 4, 12 pi over 4, 13 pi over 4, 14 pi over 4, 15 pi over 4, 16 pi over 4, 17 pi over 4, and you would look at it the same way as pi over 4. Okay, so that's the other way you could look at it. So this would be equivalent to the cosine of pi over 4, and it's not going to change anything about your final answer by doing that. So the cosine of pi over 4 is,
2 over 2.
yep. And if you had like a cotangent of a big one, I would use the tangent value and then just write it as 1 over, or flip the tangent value if it's like already a fraction for the one that already is a fraction. Any questions about those or any of this?
I'm a little confused on like the first problem we did with the
The coterminal one? What part of it are you confused about? Or are you just confused about all of it?
I'm just confused on like how we know what is and what is, I guess. Like how we knew that the negative 5 pi over 3 was.
So basically, I started with whatever the first one was here. Now, sometimes the first one might not be coterminal with anything, so it might be a bad one to start with. But I always am like, you might as well start with the first one because, go in order, right? So I added increments of 2 pi. And so in this case, it was 6 pi over 3. So I added 6 pi over 3, and I got to 11 pi over 3, which was one on my list. So I'm like, okay. Right away, that tells me that those are coterminal with each other. So I know that's not, I can put a check mark over both of those. Then I looked and I was like, okay, well, other than 365 pi over 3, the rest of them are negative. So let me try starting with 5 pi over 3 and subtracting 6 pi over 3. So I subtracted 6 pi over 3 and got negative pi over 3, but that wasn't on my list. This, however, would also be coterminal with that. Okay, so then I was like, well, let me see if I subtract another 6 pi over 3 because I'm not negative enough yet because negative 5 pi over 3 and negative 7 pi over 3 are more negative than that. So I subtracted again and got to negative 7 pi over 3. So I knew this one was also coterminal. But I know then I've already subtracted 6 pi over 3. I went from negative pi over 3 to negative 7 pi over 3, meaning that no value in between that can be coterminal with it. So that's why I went to that. And then I just didn't test 365, but it's going to work.
Okay.
Because I've already found the one that doesn't, and they said find the one that doesn't.
How do you decide that, like, how come instead of using 2 pi, you use 6 pi over 3?
Because it's fractions, and I needed a common denominator.
Okay.
Because I didn't want to be like 5 pi over 3 plus 2 pi. Because then I can't add that, and I'm going to end up converting it to 6 pi over 3 anyways. So I just do this from the start just to make life easier instead of be like, I'm going to add 2 pi. Okay, well, now I need to have this as 5 pi over 3 plus 6 pi over 3. And then I'm just going to have to do that. I just know that anything that's, like, going to reduce down to 2 pi is what I'm going to use. So this could be, 4 pi over 2. It could be 6 pi over 3, 8 pi over 4. Huh?
So we use the denominators.
Yes.
Okay.
12 pi over 6. These are going to be the common ones that we use because those are the increments that are on our unit circle.
Yeah.
And that's typically what I'm finding something that's coterminal with. Now, last year, I think you had a couple that were like, find something that's coterminal with like 15 pi over 9 or something like that. That would just be 18 pi over 9 would reduce to 2 pi. So whatever these are, just have to reduce to 2 pi. And those are the increments that I would use. So theta plus or minus these. It's easier just to say 2 pi and tell you to get a common denominator with whatever you're doing. Which this year's Algebra 2 class has really struggled with that comprehension factor of how do I know that's 2 pi? And I'm like, the same way you would find, like, I was like, ignore the pi. Like, the same way you would get a common denominator for a normal fraction, but they just really don't like fractions, so I think that's part of the problem. But they're starting to get it, but the first, little bit, it was not comprehending whatsoever.
This is why I've befriended the fractions, so I can understand them better.
All right, so your problems, and then, Virginia, I will give you your unit circle. 1, 7, 9, 13, 15, 19, 23, 25, 27, 29, and 31.